Welcome in the third section of our course. In this section, we'll be performing anomaly detection. So in the first video, we'll focus on the anomaly detection problem. So we'll try to explain what is an anomaly, when it can occur, and how can we find it. Next, we'll be extracting features from input data using multi-layer approach, and we will be preparing that for next step, that will be adding a layer that finds an actual anomaly in our input data. Once we will have all things together configured, we'll be testing and validating results from our deep learning model. And this is a video in which we'll be doing an anomaly detection problem explanation. So we'll see what is an anomaly and how to find an anomaly. We'll be looking at the process of finding anomaly using deep learning approach. So let's first answer a question: what is an anomaly and how to detect it? So here we have a chart that has some kind of specific value. We can assume that this is, for example, the number of requests to our website. And then on the y-axis there is a time. So when time flies by, we have similar value. We can see that our number of requests is similar. But then at the specific point in time, the value that we are measuring is going up. And this is not by 10%, 20%, but by couple 100%. And based on the history, we can see that it is an anomaly. So this is a very simple anomaly detection algorithm because it uses only one feature. Well, our feature is number of requests. But in the real world, we can have multiple variables, multiple features. So for example, HTTP request can have multiple fields, and only when taking into account all of them, we can find out an anomaly. So anomaly detection can be used in the fraud detection problem. For example, we can model normal data based on the input. So based on the history data and features, we can train our model to find out if a data is normal. New data point, new record features arrive to our system. We will apply the same logic that we did when train our model. So we'll use that model that was already trained to know what an anomaly is, and if it is an anomaly, it is an outlier, we can alert some external system to react accordingly. Also, from this standard machine learning approach, we can use clustering. So having multiple input data, we can access and assign that data to a specific vector. So based on the features, one record can be, for example, going to the red cluster on this picture, then another to the green one, and next one to blue one. And then when we have millions of data, we can see that after applying some clustering algorithm, for example, 3 clusters can form. It can be more, less, and so on, but we will have 3 clusters, for example. And if the new data arrives, we are applying the same logic, and it turns out that the point is far from the every cluster in our system, we can treat it as anomaly as well. Let's examine our task. So our task will be to load image data, MNIST dataset. This is a dataset that is open source available with some digits that can be used to train different models. We'll configure neural network to classify our data, and then based on that classification, precision, and other measurements, we'll take top 10 images that has best score and take top images that has worst score. So we'll be leveraging the fact that MNIST dataset is distributed normally, so the outliers from the left-hand side of the distribution and right-hand side will be taken as anomalies. And then we will see that we will find out an anomaly.